Okey, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih Chairperson Dr. Azizi dan juga welcoming remark daripada Prof. Fakarudin lah, sahabat saya. Dan terlebih dahulu saya mengucapkan banyak terima kasih kepada pihak UTM, khususnya School of Mechanical Engineering. School of Mechanical Engineering kerana sudi untuk menjemput saya pada sesi pada petang ini untuk berkongsi pengalaman lah, bukannya nak kata memberikan ceramah ke apa. It's just a sharing of knowledge, sesi perkongsian ilmu. Mungkin ada manfaatnya bagi staf-staf yang baru maupun staf yang lama lah. Mungkin dari segi perkongsian yang saya akan berikan pada petang ni lebih kepada memenuhi keperluan Engineering Accreditation Council. Maknanya lebih terus kepada straight to the point. Kita bukan nak go to the principal knowledge fundamental on complex problem solving dan sebagainya, tapi lebih kepada how do we address the requirements by the Engineering Accreditation Council. So sebentar. Okey, berkaitan dengan tajuk yang diberikan, iaitu berkaitan dengan knowledge profile, complex problem solving and complex engineering activities. So untuk makluman semua, Prof. Fakarudin lah dia meminta saya berkongsi sedikit berkaitan dengan pengalaman terutamanya sebagai panel yang melihat aspek ketiga-tiga aspek ini di dalam kurikulum apabila kita buat penilaian akreditasi, dan juga mungkin sedikit sebanyak pengalaman saya sebagai ketua program ataupun ketua jabatan di Jabatan Kejuruteraan Aero Angkasa UPM. Pengenalan yang diberi oleh Dr. Azizi itu memang betul, cumanya saya bukan lagi ketua jabatan. Actually 2 kali ketua jabatan. So cycle tu after 10 years jadi ketua jabatan, dan dah tak jadi ketua jabatan since Oktober. Cumanya mungkin dari segi penglibatan sebagai aktif di dalam sebagai panel EAC dan ETAC sejak tahun 2007 lagi, dan sebagai members of the Examination and Qualification Committee di Board of Engineers Malaysia and Quality Committee also at the Board of Engineers Malaysia, and involved in many accreditation exercise throughout the country lah, through MQA, through SWA akreditasi di UPM dan juga Uni 10 kalau tak silap saya pada tahun lepas. So okay, straight to the point. Memandangkan tajuk yang diberikan tu memang tak ada penjelasan untuk setakat mana kupasan ataupun perkongsian yang boleh saya buat pada petang ini, tapi saya telah himpunkan beberapa point ataupun melalui slide yang saya akan kongsi pada petang ini. Memandangkan petang, sesi petang, mungkin tuan-tuan dan puan-puan yang pada petang ini daripada pagi tadi dah ada bengkel dan petang nak dengar berkaitan dengan kurikulum pasal complex problem lagi, it would be difficult probably. So it's just a sharing. Normally izinkan saya beri pembentangan ni dalam bahasa Inggeris lah. Mungkin kalau ada persoalan mungkin kita boleh teruskan dalam bahasa kebangsaan nanti insyaAllah. So in terms of the content, I have roughly around 54 slides. However, there are only 46 effective slides, meaning that I'm going to share with you what are the requirements with regards to the Engineering Accreditation Council. Okay. I'm going to look into the requirements for the engineering programs accreditation standards 2020. Based on that particular document, we will look into the aspect of complex problem solving that are required by the EAC standard manual, as well as some example, my personal own example with regard to complex problem solving, and then we will look into how we address complex engineering activities through the curriculum as well as the knowledge profile, and of course the summary and some related documents that I've been using to prepare this particular slides. Just to let all of you know that normally we conducted the session for 2 days. It is a 2 days workshop to address all of these elements. but nevertheless, we tried our very best, to summarize it throughout these 54 slides for the purpose of the revision. I know that there are many participants today. They are already well known in terms of the items, but as mentioned by Dr. Azizi earlier, that there are also staff newly appointed, and maybe they are more beneficial to them rather than to the all-timers lah. Okay, looking into the first segment in terms of the introduction, engineering accreditation requirements. This is the document that we are referring to. Okay, it is the engineering program accreditation standard. And for those who are not familiar with the document, probably it's best for you to download the soft copy. It is available in the EAC website, and so that you can get familiar with it, because it's very important, not just for the head of department, the program coordinator. It is actually meant for all staff that are involved in the teaching and learning of any engineering program, to get yourself familiar with the terminology, with the items stated in the EAC Standard 2020. All right. Before we go any further, I think it's best for us to look into the terminologies that being used by Washington Accord, right? So these are the item that maybe is much more relevant for our topic today. Maybe you have seen this particular slide if you went to any EAC training conducted by Engineering Accreditation Department. So these are the standard slides where we I expose the participant with the terminologies. When we say complex problem solving, it is being used throughout the engineering program. Without any complex engineering problem solving, normally we call it as a complex engineering problem solving, the particular program is not considered as an engineering program. So throughout the curriculum, the program owner has to ensure there are sufficient elements of complex problem solving being used throughout the teaching and learning exercise. At the same time, the term used here is EA for complex engineering activities. Apart from the complex problem solving, a particular curriculum related to engineering must encompass complex engineering activities. Where can we address that items? Probably later I will share with you how do we address the complex engineering activities throughout our curriculum in UPM. So not to forget the knowledge profile, okay, knowledge profile, which are the requirements of the Washington Accord, as well as the graduate attributes. But for this particular session, I'm not going to dwell in terms of how to write program outcomes and so on, but it is interrelated. Let us look into the first item, the knowledge profile for engineering program. It is being stated by earlier in the International Engineering Alliance, some literature there mentioning what are the definition of a knowledge profile. So basically, it is the broad characteristics, okay, of the different components of the knowledge embodied in a program. Let's say you are having an automotive program, you are having aeronautical program, or you have a naval architecture program. So each one of the program has their own knowledge profile, meaning that it has to fulfill the basic, the fundamental core courses, as well as the advanced courses that fulfill the particular program requirements. It also being used to provide additional guidance on curriculum design and review. All right. So if you want to read further in terms of the explanation, you can refer to the EAC standard, page B7. So that's why I always put my reference there where you can refer it directly. So it's much easier to do that rather than we go through one by one. So if we look what is the knowledge profile in more detail, in terms of the conceptual, what is knowledge profile and why knowledge profile is important, right? So if we look there, the knowledge profile itself consists of certain elements in terms of the natural sciences, engineering fundamentals, which is specialist knowledge, which is we can say that the specialist knowledge is built on the engineering fundamentals, and the courses for engineering fundamentals is rely on the natural sciences courses. So which also relate to the or rely on the WK2, which is the mathematics. This is when you craft your design, your curriculum, it has to fulfill all this WK1 until WK4. So you cannot run away with this aspect. No matter whether you are doing aeronautical course or chemical engineering or civil engineering, it must have this element of WK1 until WK4. And apart from that, okay, contextual know-how. Just now, what in terms of if we are learning thermodynamics, we are learning material, we are learning fluid, we are learning basic fundamental sciences. So those are the WK1 until WK4. However, for the know-how, the application of knowledge is covered through WK5, which is the engineering design aspect of the design, and then the engineering practice, WK6 and WK7, comprehension of the role of engineering in society and identified issues in engineering practice, normally being covered through the engineering and society course. And at the same time, we have the WK8, sourcing of knowledge, where we expose the student through research literature. Okay, this is the backbone of what is the knowledge profile for a particular program. Okay, probably this is just a revision. You can easily read through the engineering accreditation standards, that this is what we meant by the knowledge profile element WK1 until WK4, which is the conceptual, and the contextual is the know-how item WK5 until WK7, and sourcing of knowledge is WK8, right? So we have 8 elements of WK there, right? In terms of the outcomes, program outcome, what WA. So we know that in the EAC manual, there are 12 outcomes, right? Under the engineering, International Engineering Alliance, in terms of the components indicative of the graduate's potential to acquire competence to practice at the appropriate level that leads to graduates who could enter employment and can be fit to undertake a program of training and experiential learning leading to professional competence, to be either professional engineer or chartered engineer. So that is what being dictated by the IEA in 2013 with regards to the program outcome. However, for our EAC, it's not that much different, where the program outcome describes what the students are expected to know, what we as the lecturer or the program owner promise the student, that what are the attributes or the outcome that the student will attain at the end of the program, at the end of the graduation. So this relate to the skills, knowledge, and behavior that students acquire through the program. So from students to become a worker, an engineer, right? So when we look into the program outcome, the 12 program outcomes stated in the EAC manual, right? So just now we already identified the knowledge profile, right? We have WK1 until WK8, okay? And now we are going to look into the WA1 until WA12, okay? So the EAC manual group the WA or the program outcome into 3 categories. The first one is what we call it as the analysis of problems and synthesis of solutions. Okay, WA1 until WA5, right? We have the engineering knowledge, we have the problem analysis, design, investigation, and the modern tools. How the student using certain software in order for them to do the learning, all right? And then in terms of the aspect of responsibilities, so the blue color box here, WA6 until WA8, So where we have engineers and society, we have environment and sustainability and ethics being grouped together in terms of the responsibility of the students through what they learn in the program. And finally, what is required in the workplace, the what we call it this as the interpersonal skill in terms of ability to work in group, WA9, communication, oral as well as the written communication, WA10, WA11, project management and finance, and lifelong learning, right? So in EAC, they didn't cover the aspect of entrepreneurship. Some programs through different institutions, they have introduced entrepreneurship because for some, it is very important, but it's not being covered through the 12 program outcome as stated in EAC manuals. Okay, so this is the knowledge profile WK, where through this knowledge profile, okay, WA1 until WA8, okay, we um, embed or we address the complex problem solving. This is how the relation looks like. Whereas through the green box, what we call it as the interpersonal skill, we address the complex engineering activities. And this is, if you can understand the relationship here through this particular diagram, you can easily relate in terms of when you want to address the requirement of the engineering accreditation standards. So where we have the knowledge profile, we have the program outcome WA, we have the WP being addressed, and we have the EA. Later on, I will share with you some example on how we map the elements of WA, WK, WP, and EA with our courses. All right. So because it's very important to align which course will address certain knowledge profile, which WK and which program outcomes, and eventually how is it being addressed through the WP, the complex problem solving, and the EA, the complex engineering activities. And the detail will be, it is being displayed in page 10 in EAC Standard 2020. All right. In terms of the summary for the program outcome, so basically, if we look here, the analysis of problems and synthesis of solutions based on engineering knowledge supported by engineering tools, techniques, and methods, okay, where we have the engineering knowledge as well as modern tools will be supporting the problem analysis, where you do the complex problem solving, complex engineering problem solving in terms of doing design and conducting investigation, right? At the same time, responsibilities of engineering practice with regard to social, economic, cultural, health, safety, regulatory, environmental, and sustainability issues are being addressed through ethical responsibilities of engineering practitioners through the following WA, which is engineer and society, environment and sustainability and ethics, and finally the personal attributes, the individual attributes, or we call it as the interpersonal skills that are essential in the engineering workplace, effectiveness as an individual and in teams, communication, engineering management, and independent learning are being addressed in this particular group of WA, the outcome. So this is the summary in terms of what are the requirements by the Engineering Accreditation Council through the EAC Standards 2020. Right. These are the attributes. I'm not going to go through one by one. Of course, I just want to display here to show where does the complex engineering problem elements will come in. At the same time, where does the complex engineering activities comes in. So if we can see here, clearly, for example, like PO1 or WA1, normally we call it as program outcome 1. There is a complex engineering problem related for the knowledge, basic knowledge. Problem analysis, we also need to analyze complex engineering problems, right? Design, development, and solution, we have to address complex engineering problems. Investigation must have complex problems. It cannot be just problems. So later on, I'm going to show you what do we mean by complex engineering problem. And then modern tool usage, complex engineering problem. Of course, when we go into, these are the main element, PO1 until PO5, right? When we go into the PO6, 7, and 8, right? There are still elements of complex engineering problem involved, even though it is not really related to the basic knowledge. And finally, where does complex engineering activities come in? Basically through PO10, the communication aspect. So the EA here, the EA engineering activities need to be addressed through the communication elements, right? So let's go into more detail, and through example probably is best for you to you can relate it to what I'm talking about just now. Okay, let us move into the next segment. Just now, in the first segment is just an introduction on what are the requirements, what are being stated, what are in the Engineering Accreditation Council program standard for 2020. So, but now we would like to go into much more detail. What do we mean by complex problem solving? Right. So again, in terms of the attributes of complex problem solving, right? So when we talk about complex problem solving, is not just one definition. There are, it is being described as WP1 until WP7, right? We have requirements of the depth of knowledge required, range of conflicting requirements, depth of analysis required, familiarity of issues, extent of applicable codes, extent of stakeholders and level of conflicting requirements, interdependence. So probably some of you, when you start to do your courses, when you try to design your assessment, you're being asked by your program coordinator, okay, Dr. Azizi, you have to address WP1 with WP4 and WP5, for example. So you have to align how you do it in your assessment, whether you are going to address it through assignments or some projects or lab works, or maybe some cases you may do it in the final exam. So let us try to go through in more detail in terms of what do we mean by WP1 until WP7 first. Okay, if you look into the EAC standard 2020, page appendix B5, it provides you with the detailed explanation. What do we mean by the attribute of the complex problem solving? Over here, okay, is mentioned that the complex problem have characteristics of WP1. Any complex problem that you declare through your assessment or in your course must have the element of WP1. It must have the depth of knowledge. Okay, it doesn't, if it is doesn't have the fulfill the first criteria, meaning that it is not a complex problem. What do we mean by depth of knowledge required? So in that particular assessment or exercise, the elements cannot be resolved. The problem cannot be resolved without in-depth engineering knowledge. At the level of one or more of the knowledge profile, WK3, WK4, 5, 6, or 8. It can be one of it, or it can be more than one, right? So which allows a fundamental based first principles analytical approach. All right, maybe some of you can grab that definition. Maybe some of you still wonder what is it all about. So maybe later when we go through example, you can see, oh, this is what we meant by requirement of having depth of knowledge. Just to note, sometimes when you just read through, you don't really understand until the point of you creating your assessment with regards to WP1. Alright, so kalau tak dapat lah. Kalau cakap saja tanpa kita practice, probably you will be at loss. So that's what happened to me at the earlier stage dulu-dulu lah. So and then what we being mentioned in the EAC standard page B5, you must have WP1. At the same time, you also need some or all of WP2 to WP7. Okay, what does that mean is that apart from having WP1 in your complex problem solving element, you also need to choose either all of this WP from WP2 until WP7, or at least they say here some or all, meaning that you need to choose at least minimum two. So in altogether you have three. So, senang faham kan? Okay. So basically apa yang saya maksudkan ialah kena ada WP1. Pada masa yang sama kena ada mana-mana WP ni boleh jadi semua ataupun katalah pilih WP2 dan WP3. Tak boleh kata nak pilih WP2 saja. So it does not fulfill the requirement here. Okay, you must have minimum 3 lah. Kena ada WP1. This is what I understand, and also that what being told by the EAD with regards to how we choose the WP. So in other words, you need to have 3 WPs in order for your assessment or your assignment to fulfill the complex problem solving characteristic, right? So that is the requirement, right? Okay, just now we look at the WP1. What is about WP2? WP2 is talking about range of conflicting requirement. Okay, it must involve wide-ranging or conflicting technical, engineering, and other issues. So there are conflicting requirements. Maybe in your situation, in the problem that you ask your student to solve, they have conflicting requirement. Maybe a requirement by the authority, some authority, some government department, for example, the Jabatan Kesihatan, they require this ruling, and then from other department, Jabatan Bomba, for example, it requires certain other aspect. So it has conflicting requirements. So that can be considered as the fulfilling WP2, right? And then what happened to WP3? Depth of analysis required. So what does that mean is that the problem have no obvious solution. It's no straightforward. So the problem require abstract thinking. It requires originality in analysis to formulate suitable models, right? So it's not straightforward lah. In other words, it has no obvious solution. For example, like you are dealing with landslide. For example, what happened in Kedah, in Kedah. So is it a straight forward problem? So some people say yes, some people say no. So of course, depth of analysis required where there's no obvious solution to that particular problem, right? And then WP4 talking about familiarity of issues, involvement in frequently encountered issues. It's not familiar issues. It's not something that, if this happen, we just do this treatment. Okay, so it is, if that is the case, we can say that yes, it is fall within WP4, where there is no frequently or familiar things that happen and there are solutions available outside. WP5, extent of applicable codes, we are looking at whether the problem is outside problem encompassed by standards and codes of practice for professional engineering, right? Where it is not the normal code of practice, where it is outside the standards. So that is a problem. Sometimes it's a problem to find a problem that does not fall within the applicable codes. So this is quite challenging to have WP5 in a curriculum, but some cases you may find out that there's no applicable codes available to address the problem. And that is already WP5, much more harder. And then WP6, extent of stakeholders' involvement and level of conflicting requirement, which is related to WP2. Now, normally, if you have WP2, you can relate it to WP6, where what it means is that it involves diverse groups of stakeholders with widely varying needs, and different stakeholders engagement is required in order for you to solve the particular problem. And finally, WP7, interdependence. Whether the problem are high level problem, including many component parts or sub problems. So where sometimes in order for you to approach a problem, you have to solve the problem in systematically, where you need to find the parameters, and then you need when you the student manage to do that, they can then use the parameters to solve the other aspect of the problem before they proceed further. So it is interdependence. So in the first place, why do we need all these elements, the attributes? Is why not just having one um, definition of a complex problem? Because anything that is not usual is complex. It's not like that. So that's why in a curriculum, or any engineering curriculum, for example, like aeronautical engineering curriculum, so the curriculum itself, the courses in the curriculum itself has to address all the WP1 until WP7. Not necessary that every course must address all WP1 until 7, but the program itself, maybe one particular course addressing 1, 2, and 3, another particular course maybe integrated design project, IDP, addressing more than maybe 4 or 5, and maybe a design project addressing certain, but at the end of the day, the curriculum itself has to fulfill all WP. So when as a panel, when they come to see your program, the program owner must be able to tell the panel assessor saying that yes, we address all the WPs through these particular courses, and you should be able to show how the WP being addressed up to the point where you may want to show the example of the assessment being made. All right. So that's what the expectation of EAC manual 2020. It's no longer saying that you have a plan, you have a plan, you have a plan, but it is more on how you implement it, and how you use it for continual quality improvement, the CQI behind it. All right. Characteristic of a engineering complex
Actually, saya
engineering
bercelah
problem.
sikit to make understand. I think maybe about this complex problem tadi tu. Kalau
Yeah, bro.
WP tadi tu, can I ask ni to make more understanding lah. So basically, when we want have a course, jadi the things that we want, which WP we choose, maknanya di dalam our syllabus content kita tu is something that is not normal, is it? Not the norm thing. Macam kata you kata tadi, katakanlah we say about professional engineering the codes. Jadi maknanya di dalam khusus kita, kita memang mengajar engineering professional punya codes. Tetapi what are you think, bukannya bila kita pilih WP ni 5 tu bermaksud bukan nanti benda yang kita ajar kan. It's something that
Yeah,
not is tu benda yang benda yang not a norm. Maknanya memang kita ajar all the ethics punya. Kita when we talk about engineering professional practice, kita have all the codes from the IEM code, Board of Engineers punya ethic codes apa semua kan. Tapi sekarang ni when we choose W5 tu as something that is not outside the code, is it? That's what you mean?
yeah, betul, Prof. It's actually um, a situation where normal codes cannot be applicable, meaning that maybe it is never being used before. That's why I said WP5 is quite difficult to address,
Yeah.
but it is doable lah, especially on integrated design project ke something yang require novelty, something yang tak ada dalam standard yang ada,
Yeah.
so
So bukanlah kita mengatakan bila kita PWP5 tu because kita ada mengajar kod itu dalam subjek tu, is not that one.
bukan
Why we choose
yes,
PWP5 kan? Bukan
it is beyond the codes that we being addressed by
Ya,
BEM lah.
So maknanya kalau dalam subjek engineering practice, tak bolehlah kita pilih W5 sebab kita memang ajar kod tu, bukan benda
Betul.
kan?
Tak apa-apa sesuai pun.
Tak betul lah tu. So I
Nanti
think
nanti kita tunjukkan macam mana nak address WP5 ni
baru kita faham, because basically whatever WP that we choose is something that is not the norm. Boleh katakan begitu ke?
Ya, betul. It's not the norm. It's not the
Not the norm
normal
that
code.
is the norm that kita ajar dalam kelas kita, tetapi benda yang tidak ada di dalam norm itu yang kita pilih WP dia. Betul gitu
Ya, betul. Yes.
Sekarang ni
That's
baru faham.
exactly correct. Yeah. Okay, very good, Prof. Pakar. At any time, if anybody would like to interject or to give their opinion, please do so. Kita lebih interaktif lah, rather than saya bercakap seorang-seorang aja. Okay, with regard to this, the characteristic of a complex engineering problem. Just now we look at the requirement, the explanation by the EAC standard. And that's at the same time, I also would like to share with you other definition of complex engineering problem. This is taken from Pang et al. So a complex engineering problem is normally something difficult to the solver. It is unfamiliar, okay, has number of variables and parameters. It's not just one set of variables. Solve the variables using this equation, you get the answer. That is not complex. So it has a number of variables and number of parameters need to be considered, and it is connected to few parts of a system or a few different systems. So in order for you to solve the whole complex system, you may need to approach one part to the other part. The solver does not have immediate solution to the problem, right? It's not 1 plus 1 equal to 2. Okay, 1 plus 1 equal to 2, and then 2 plus 7 equal to 9. So there are a few steps, so many steps in order for you to reach to the problem that is complex. And the solver need to define the problem prior to solving it, meaning that in order to approach a complex problem, is the student themselves need to put their assumption. What are the assumption? Is it what are the boundary conditions, whether it's experiment or it's a simulation? They need to put the assumptions in before they can approach the problem, right? And the solver need to develop his or her justification for the solution. It's maybe at the end of the answer question, the student need to provide their justification, their comment on what's happening in the situation that they are solving. So that is what according to Pang. Let us look into furthermore, a complex problem, in summary, need to think broadly and systematically and see the big picture before any decision be made. A difficult decision, maybe you based on the big picture, you have to address all the elements, okay, and uncertain strategy. Of course, there are risks behind it. Maybe some student approach different way, another student approach a different way. Okay, so confusing idea, contentious product, and intractable change. So these are another elements of complex problem. At the same time, when we talk about difficult and uncertainty, when we talk about complexity, and the problem contains a large number of diverse, dynamic, and interdependent elements, and in terms of measurement, it is difficult or practically unfeasible to get good qualitative data. And some say that yes, we need novelty, right, in order for us to solve complex problem. There is a new solution evolving or an innovative design is needed. Okay, just to ask you, all of you, why do we need complex problem in the curriculum? Okay, is it that For example, like Prof. Fakar mentioned just now, we are teaching our students certain codes, right? That are available in the Board of Engineers, certain standard practices, standard operating procedure in certain ministries, certain jabatan, and so on. But why do we require complex problem solving ability to our students? And the answer is that because we want the student to solve future problem probably not the same condition as what we have today, right? So maybe the boundaries are different, the scopes are different, so maybe there aren't any applicable codes outside there. So that's why the IEA, as well as of course the Washington Accord, and our Board of Engineers Malaysia put a strong emphasis on a complex problem. It is not new. It is already there since our first ESC standards way back in 2005, right? But the recent ESC manual is being stressed, is being emphasized for the each curriculum to pay more attention into what is complex problem. So to continue, okay, the some other inputs from other people saying that a scientific or technical problems, okay, if you combine it, if you compile it, it can become a complex problem. If it is just one technical problem, maybe it's not complex, but if it is a combination of a few technical problem, it can become a complex problem. If we look carefully in terms of the characteristics, a technical problem as well as a complex problem. Some lecturer say that they address already all the complex problem elements, okay, in year 1 or year 2 in the curriculum. Is that possible? Some say that, oh no, we cannot address year 1 with complex problem. Maybe not all, maybe just 1 or 2 elements, but some say yes, we can address a complex problem at the early stage. So if we look at the comparison between a technical problem and a complex problem, over here, a technical problem, normally it is, you can isolate it, isolatable, boundable problem. You can isolate, you can also have a boundary. But for a complex problem, normally there's no definitive problem boundary. So technical problem, universally similar type. A problem in Johor will be the same in problem in Selangor and also in Kedah. But complex problem is relatively unique. Problem in Kedah maybe not the same as a problem in Johor. So it is unique in terms of it is unprecedented. So a technical problem normally it is stable or predictable problem parameters. You have you can predict the problem parameters, but a complex problem normally you cannot. It has unstable and or unpredictable problem parameters. Okay, and a technical problem also require multiple low-risk experiments which are possible and doable. Maybe a complex problem, it is not possible. A technical problem has limited set of alternative solutions, right? Maybe you cannot do solution A, you try solution B. That is a technical problem. You do troubleshooting, right? But a complex problem, normally you don't have bounded set of alternative solution because it is a new problem, a new set of problem. That's why to create a complex problem question is complex. It is difficult. So involve few or homogeneous stakeholders in technical problem, but complex problem require multiple stakeholders with different views or different interests, right? And a technical problem also has single, optimal, and testable solution, whereas in complex problem, no single optimal and or objectively testable solution. Technical problem also has single optimal solution can be clearly recognized, whereas complex problem, there's no clear stepping point. You can see that sometimes you declare it is complex problem, is actually is just a technical problem. So how to avoid that? And there are certain approaches that we can share for this afternoon. I hope everybody are still interested to know. Right. Some study by Pang et al. They say from the same paper. They publish it in Engineering Education for Smart Society. So I think you can easily download it from the website there. Some responses from the lecturer: how do we design complex engineering problems? There's the same problem again and again being asked by the program owner. And normally when the examiner or the panel assessor come in, and they will ask, how do you design your complex engineering problem? Okay, sometimes people will say that, oh, the questions are integration from several topics. It says it's just a complex problem. For example, it must has elements of thermodynamics, it has elements of material, it has elements of electronics over there, it has elements of ethics. So we combine it, becoming a complex problem. So that's what one respondent said. So another respondent mentioned that it is related to the syllabus. We never teach before, but provide handout or give short briefing about the project. The student need to find on their own, like an open-ended. Go for interview and learn how to get the information from other people. Students are out of the comfort zone. Is it enough to address complex problem? Another respondent mentioned, I did like C, like the first respondent there. I related all the other topics while teaching highway subject. Another respondent say, so far, it is difficult to design a complex problem in examination, final exam, for year one, because the lessons are very fundamental and not specific. Is it true we cannot design complex problem for year one student? So normally people will a certain program that I evaluated, they just put it as all the complex elements are being done or being focused to culminating courses, right? Culminating courses meaning that maybe through their IDP, through their final year project, maybe for their design project, and everything being done there. All the complex element. Year one, year two, year three, no complex at all. Only low level of cognitive, low level of assessment. Is that correct? Okay, I don't say it's wrong. So that's the way they do it. And then another respondent mentioned here, I design complex problem in a case study because it is open. Students create the problems, think independently, they measure and find their own solution. So they need to identify the problem first. So if you read through the response given by the respondent just now, some of it already addressing WP1, WP2, WP3, and so on, right? So because it is complex through the definition. And then another person say the task is more on complex activities. Consortium to solve the problem must integrate to find the result and involve more integration activities. And finally, each of the level has their own complex problem, right? Meaning that year one has their own complexity, year two, and so on. And final exam is not suitable to design complex problem because complex problem consume time. If you put up a complex problem in your final exam, make sure you have ample time for the student to address it. It's because there's no, if not, it's not going to be a complex problem actually. It's just a technical problem, right? Let us move on. Just an example, taking from chemical engineering. I think I will just read it aloud. An example on final exam on a complex engineering problem. Okay, in this particular case, maybe some of you have seen this in EAC training. Sungai Melana is a small river flowing through several residential areas in Skudai. You are a consultant appointed to propose a river restoration action plan. Okay, for a part of Sungai Melana beginning from the upstream of Taman Teratai until the midstream of at Taman University. Your proposal should include action plans to accomplish the following objective. 1, 2, 3, 4. So your answer should be written to address each of the above items separately. 20 marks there. So you imagine the student when they want to approach this kind of question, they have to plan carefully. What is actually they need to do. So what is actually they need to propose? Is it a straightforward question? No. It is a it is there are so many elements that they need to fulfill. For example, improving the water quality according to the standards here, prevention of direct solid waste discharge into the river, creating suitable habitats, adding property and aesthetic value. So there are many stakeholders involved. Eventually, basically, if we do this as a workshop, this is an example of exercise where participants then identify, oh, this is what is it WP1 and WP2 and WP5? Is it a different WP, and what knowledge profile being addressed here? So those kind of activities. Of course, for this afternoon, we are not going to do that because it's just a sharing session. We do not have enough time to do the activity. And then let us look into another example from civil engineering, example of an assignment that is a complex engineering problem. All right. Before this final exam, this is a assignment about two villages in Timbuktu are separated from each other by a valley at its deepest section about 30 meters. And the valley is dry all the year round except for the 4 months, monsoon lah kononnya kan, from October to December each year, where torrential rainfall can flood major parts of the valley to a depth of over 12 meter. Okay, they have been given a situation over there. The soil is generally lateritic with firm bedrock underneath. A bridge connecting the two villages is in a state of disrepair and has to be replaced. So you have to write a project brief on how would you approach to design for the replacement bridge. You are limited to use locally available building materials. Heavy equipment is not available for the construction. So this is an example of a group project assignment for civil engineering students. So they've been given for a couple of weeks to address, and normally when we do the workshop, we will ask them to identify what are the WP are expected from this particular example. What is important from ESC perspective? Another example here is my very own example. Just now chemical and then civil. I think it's best for me to show what is aerospace engineering students do for complex engineering problem solving. So I share with you our integrated design project. In the EAC manual, it mentioned there clearly that the integrated design project shall involve complex engineering problems and design system components or process integrating culminating core areas, okay, and must consider public health, safety, cultural, societal, project management, economy and environmental. Semua ni kena address. Kalau you punya IDP tak address one of it, it can become a concern. Kalau tak ada IDP, jadi weakness. So kena hati-hatilah. So sometimes you address certain thing but not addressing, for example, project management. Tak ada project management dalam IDP. So boleh jadi concern because does not fulfill the requirement. Okay, so let us look into how we approach it. For example, here it is related to PO3. This is related to our very own program outcome. We have 13 PO for your information. Apart from the 12th PO, we have entrepreneurship and management, financial and economic. We have it in PO 13. Right. So how do we address basically for the IDP for this in the integrated design project for aerospace engineering? The students are required to, in a group of 5, and they have to come up with a design of a particular platform. It can be a fixed wing or it can be a quad rotor. It's just a platform of aerial vehicle. So where they have to perform certain tasks. They have to do from design to fly, meaning that they have to come up with all the parameters, they have to come up with all the requirement, they have to fulfill the mission profile, and then they have to demonstrate the project. It's not just a design element. It is integrated design project. So the program outcome that being addressed through this IDP course in aerospace, where the students are required to fulfill so many PO regarding to knowledge, design, modern tool, ethics, individual and teamwork, project management, entrepreneurship, and communication. If you look carefully here, in terms of the knowledge profile being addressed, we have WK1 until 4, WK5, and WK6, right? Where the complex problem solving as well as the engineering activities, we have WP1, WP3, and WP6 being addressed through the assessment that we made for the student. Okay, and the communication side, we have the engineering activities, EA2. And later when we go into engineering activities, I will explain EA. What is EA2? We have EA1 until EA5. At the same time, we put up...
PO12 tu dia konektif juga
Oh,
project management.
PO12. Yes, it is addressed through connective
Dia
in
technical
our project management.
It's a technical juga. It consider dekat it's a technical lah.
It is, yes, Prof. Meaning that basically the student need to apply, meaning that they have to, in their particular report, they have the project plan, how they address it. So we assess it through rubrics for the project management.
Oh, dia bukan generic skill
Bukan. Ini yang kami punya example lah.
Oh, yalah. That's why maknanya PO12 project management can also become cognitive, not only generic skill.
Yes.
Okay. Alright.
Okay.
Thank you.
Alright. Thank you for asking that. Maybe sometimes people tak perasan. Kalau dia tak buat, dia tak perasan lah. Mungkin Prof Akar mungkin pernah address project management.
Bila come to project PO12, project management and safety ni, kita di sini kita is a generic skill.
Okay.
So kita tak pernah sampai pergi konektif. Correct me or I'm wrong lah. Kalau tak tahu, saya rasa macam itulah kat sini. Kat UTM. Mana mechanical lah. I don't know where ada school. Tapi tak tahu, Prof Isman. Mungkin Prof Isman boleh mencelah.
Tak, kita bila tak Excel, kita pakai kognitif. Encounter assessment we use as cognitive, C4.
Okay, meaning that is the same lah. Maknanya for assessment, siapa cakap tadi? Prof Isman
Saya.
Yeah, so it's same here where but the Bloom taxonomy level is only C3 So
apalah, maknanya whichever Bloom level tu tak apalah, maknanya
yes.
Basically mana project management PO12 can go up to cognitive lah, not only generic skill saja.
Betul lah. Okay, then what happened is that this is just showing how our mapping between the course outcome and the, of course, the marks lah, yang ni kita terangkan pada our students, the distribution of the domain, and then what is important here is basically that the lecturer themselves need to plan carefully how do we address or assess the student in terms of all the elements of, for example, like the WK as well as the WP and EA. So assessment through this IDP, this particular subject IDP is not being conducted by just one person. It is consists of 4 lecturers, right? And then we have our assistant through our assistant engineer. So it's not just one man show, because there's so many elements of I don't know, in UTM you are conducting it just one person, one man show ataupun ramai-ramai. So kami buat cara berjemaah lah, because there's so many elements of assessment need to be done. Right? So the assessment is being through our IDP is being breakdown in terms of the item that the student need to prepare. For example, the proposal, logbook, minute meetings. For example, like ethics is exam. We have a written examination for the IDP with regard to ethics. Ada soalan bertulis. So it's not just sebelum-sebelum ni kita guna just looking at the plagiarism checking, but no more. We have we ask them about certain codes, because since it is related to aerospace, we ask codes related to the CAAM, Civil Aviation Authority Malaysia. What are the relevant codes that are applicable to the project? Interview, the teamwork kita buat secara interview. So presentation and report and product demo. Right? So those are the elements. In terms of approach, when when you want to design a complex engineering problem solving question, so basically it must have, I don't say all the element has to be included, but maybe some or maybe all of the elements. For example, the aspect of economics has to be can be included, social, environment, ethics, management, technology, analysis, and evaluation. When the student approach the situation, they may need to look at different aspect of this. Maybe some, maybe certain, or maybe all aspect in order for them to address the problem. At the same time, when we talk about the approach thinking, when in the example of the Timbuktu bridge design just now, they have to look at the site conditions. They have to look at the aspect of the weather, available technology, building materials that are available over there in terms of the design, costing, scheduling. So they have to look at the big picture before they come into providing their solution, and providing the assumptions and justification when they choose certain approach, right? And of course, the approach in terms of the solution, they can adopt problem solving skills, and there are so many problem solving skills available. They can start to formulate the problem, maybe do some literature background, and perform their experiments or simulations in order for them to come up with the answer for the complex engineering problem, right? And then in terms of the assessment, like what I shown you just now, in terms of the IDP at our UPM, so it can be assessed through report style and content in terms of the flow of the report. Okay, and maybe you can use a presentation, or a model showing demonstration of product, for example, like our drone IDP project. So we want the student to design, fabricate, and then fly it, perform the project. So they have to show that if it is crash, it's okay, but they have to tell us why your product crash and so on, right? Viva or articulation through presentation, interview. This is very important. Sometimes this is to avoid student that are just becoming a passenger in a team. So we can see the teamwork. We get involved with the team meetings, management, and scheduling. So the so many approach in terms of the assessment can be done to address the complex problem solving. Right. Let us move into complex engineering activities. I think I've already taken so long for complex problem. It's already this is our third elements of today's presentation. Okay, complex engineering activities, where earlier we mentioned complex engineering activities, but we didn't go through what are the requirements of complex engineering activities based on the EAC standards. So there are 5 engineering activities stated in the EAC standards, where we have EA1, where the activities has range of resources, EA2, level of interactions, having innovation, having consequences to society and environment, and familiarity. So you may address some or all of the EA1 to EA5 to show that yes, you address the engineering activities, complex engineering activities. So the standards mentioned in page B6 is just next to the complex engineering problem, right? So B5 is complex problem solving, B6 is complex engineering activities. So let us look into the attributes, the definition of complex engineering activities. In terms of the complex engineering activities or projects that have some or all of the following characteristic. Okay, the first one is range of resources involved with the use of diverse resources, and for this purpose, resources include people, money, equipment, material, information, and technologies. For example, like you are conducting engineering and society course, right? In our case, engineering and society course is we have the theory part and the practical part. So the practical part will address EA1, where the students are required to go to the society, to the community, and to find problem, try to solve the community problem, and then they will come up with their own solution together. This, of course, discuss with the community, and having it is open ended. That kind of project can be declared as addressing EA1. Whereas EA2 require resolution of significant problems arising from interactions between wide-ranging or conflicting technical, engineering, and other issues. If you read carefully, it sounds like WP2. WP2, the apa ni tadi, complex problem solving tadi, WP2, different level of interaction. So let's say you in this particular case, it is the activities that require different level of interaction. And then innovation involve creative use of engineering principles and research-based knowledge in novel ways, right? So when the student doing their project, that's why EA normally being addressed in PO10 in communication, right? So you may have different projects throughout the course, right? Maybe one particular project in one particular course addressing EA3, another one addressing EA2, and another one addressing EA1, and so on and so forth. Doesn't mean that one particular project has to address all the EA. And then EA4, significant consequences in a range of contexts characterized by difficulty of prediction and mitigation. And finally, familiarity of issues, where the students are expected to look into beyond previous experiences by applying principle-based approaches. It is outside the familiarity issue, is because we want to look into complex engineering activities. It's not something that is they already encountered before, and so it is something that is outside their norm. What mentioned by Prof. Pakar tadi betul lah. This outside of the norm, something that is complex. So exposure to engineering practice, I would like to relate this to complex engineering activities, where it is also being mentioned in the EAC standard, where in order for to improve the engineering activities for the student, you can have lectures or taught by guest lecturer from industry, academic staff with industrial experience. That's why it's very important to have your staff to have certain numbers of years in the industry. And then having courses on professional ethics and code of conduct, of course, conducting industry visit. But now it's very difficult to conduct industry visit. Maybe virtual industry visit will be doable. Industry-based projects, some projects, fourth year project or final year project are not are having industry-based project. They when they went for their industrial training, when the student come back, they bring industry project together. And regular use of logbook in which industrial experiences are recorded also can improve in terms of the exposure to engineering practices. So I just purposely put it here so that you can relate it back to the engineering activities. Okay, in summary, the last part of the presentation, when we talk about OBE curricula, outcome-based education curricula, the curriculum shall provide students with ample opportunities for analytical, critical, constructive, creative thinking, evidence-based decision making in dealing with complex problem solving. Whatever it is related back to complex problem solving, because this is an engineering program. Where if it is an engineering technology program, kita lain cerita lah. It's a broadly defined problem solving. So ada juga tu, tapi yang ni is complex problem solving. And the curriculum shall include sufficient elements for training students in rational thinking and research method, right? And how does complexity relate to curriculum? So as I explained earlier, the complex problem can be addressed through general courses, not necessarily through final year elective courses, and can also be embedded in industrial placement. You can have it in core and specialist engineering courses addressing complex problem solving. Elective courses, complex problem solving, design project or integrated design project, IDP, for complex engineering activities, as well as final year project. So those are the things that need to be addressed in the curriculum. For lab work, how can a laboratory activity can also address complex problem solving? Throughout the program, there should be adequate provision for laboratory or similar investigative work. So I believe a program in UTM, especially the aeronautical program, has like a consolidated lab activities, meaning that the lab is separated from the courses. So you have lab 1, lab 2, aero lab 1, 2 and 3 and so on. So where it has a build up of investigative work. So some of it are guided activity, and there are also elements of open-ended. But more importantly is that the student will be exposed to have confidence to deal with complex problem solving. That's already being addressed in the curriculum. So laboratory work is not tidak terkecuali from the addressing laboratory work. Industrial training, okay, even though it is an exposure to the practical in the industry, so it can be said that at least the student will have the capability of carrying out complex engineering activities, meaning that they're being exposed to the real environment. That's why we at the panel of EAC, when we look into a particular program, we want to see the industrial training being conducted at the relevant industry. There are cases the industrial training are not, the student are being sent to other than the program specialty lah, meaning that let's say it is automotive, they send the student to food process facility. So doesn't suit well with the automotive program. So because at the end of the day, we want the student to have enough exposure to carry out or to learn about how the industry people conducted complex engineering activities, but not to acquire craft skill. So we don't expect them to do practical. If they do practical over there, is kind of like a bonus. And of course, I already mentioned about IDP just now, example of our own curriculum, complex problem solving, right? And what else? Self-assessment report. So in your SAR report, I think Prof. Pakar already mentioned about this requirement of the EAC, where you need to write not just writing self-assessment report is just to tell what you do, basically to show proof how you do it, how complex problem solving and complex engineering activities have been addressed effectively. In other words, yes you have, and how effective. Dia kena pusingan seterusnya, apa tahap seterusnya, how effective is your assessment. So describe exposure to professional practice and relate it to the PO. Of course, it is very important to highlight complex problem solving and complex engineering activities, as well as the knowledge profile being addressed in the curriculum, right? And since it is a self-assessment report, we do expect there is a self-assessment. How do you self-evaluate? Of course, you have your stakeholders, you have the external examiner, you have the industry advisory panel, you have your alumni, you have students feedback, but the program owner feedbacks, how do you assess whether how far have you addressed your complex problem solving elements? Is it that the level is still level 1, or you are already gone through the CQI of the implementing complex problem solving and complex engineering activities? Before I end, I just want to show our recent workshop dekat Fakulti Kejuruteraan, pemetaan antara di program outcome, WA, knowledge profile, program apa ni, complex problem solving, the engineering activities and the taxonomy for our POs. So how do we have that in terms of the EAC requirement, the domain, and then we have the PO, we have map it into UPM punya PO lagi, knowledge profile, as well as the complex problem solving. For example, EAC1, if any particular course addressing PO1, it will address WP3 and WP7. Because our previous curriculum, we make it open. Meaning that open ni maknanya suka-suka siapalah nak address WP mana. But in our latest curriculum that will be used this coming October, kita dah put like a guideline lah, maknanya it's not cast in stone, but basically we in order for us to ensure all the WPs are being addressed, so that we can track all the WPs being addressed in which particular course. Bila kita ada mapping dengan courses, kita nampak dah PO6, mana-mana kursus yang addressing PO6, they have to address WP3 and WP7. You can see here WP5 in our case being addressed in engineers and society, so going to be tough and difficult, okay, but can be addressed through the project, okay. EAC10 communication, PO10, that is where we address the EA. So the EA, we didn't dictate which EA. It can be EA1 until EA5. Any courses that addressing PO10 will also address at least 2 of the EAs dalam apa ni yang kita plan lah. Yang ini tak tahu lagi sama ada jadi macam ni ke tidak. And then before I end, pemetaan between courses, as I said just now, yang ni example coming from our Deputy Dean, kita ada the course, and then kita ada dia punya course outcome, kita ada dia punya PO, we have the knowledge profile, we have the WP that they address, minimum 3, 1, 2, 3, yes, or everything is 3, and then the EA, wherever they address EA, PO10, they will address EA. So throughout the program, we make sure that all the EAs are being addressed and all the WPs are being addressed, and we make sure we can do CQI afterwards. All right. So reference document, just a reference document from various speakers. Kita ada Engineer Abdul Aziz, some of you know him. Kita ada Prof. Aliani Ismail, our Deputy Dean Academic, Dr. Ahmad Salahuddin from Department of Aerospace, and then we have the Engineering Accreditation Department, EAC Standard, and Prof. Noka Mariah Nordin, our mantan dekan lah. So with that, maybe if you have any question, you may ask. Maybe kita boleh discuss lah, because ni sharing session kan. So I pass back to the Dr. Azizi. Maybe kita boleh have maybe ada soalan dalam chat box tu, saya tak pasti. So I pass back to Dr. Azizi to moderate the session. Silakan.
Alright, okay. Terima kasih. Thank you very much, Prof. Rahim.